Hi, this is Algebra 2, Lesson 85. We're going to talk about systems of nonlinear equations, and we're starting on page 350. The graph of a first-degree polynomial equation in two unknowns is a straight line. So we have y equals 2x minus 4. If we graph this, it'll be a straight line. And we call that a linear equation. We also have 3x minus 2y plus z equals 17. This is also a first degree polynomial, but it has three lines. So its graph isn't a line, it's a plane. P-L-A-N-E, not plane as in a plain bagel. And it would be graphed on three axes, which you will get to much later. Nonetheless, we call this equation a linear equation because it's a first-degree polynomial of two or more variables. Because that's the definition of a linear equation, these are also linear equations. 4x plus 2y minus 3z minus 6k equals 15, and 3x plus 7y minus 2z minus 6p plus 3m minus n equals 21. You don't want to graph either of those two without a really, really expensive computer. But they are linear equations because each of the terms are just 1 degree and there are two or more variables. Equations of a degree higher than 1, so that either a variable has an exponent that is greater than 1, such as x squared plus y equals 5, or x squared plus y squared equals 7, or where there are exponents multiplied times each other, so xy equals 4, or 4x minus xy equals 7. These are all 2 degree polynomials. These all have graphs that are not straight lines, so we call them nonlinear equations. We're going to be talking about a subset of nonlinear figures called conic sections, because they can be formed by a plane, which is a flat surface, cutting a single right circular cone, or a double right circular cone. You remember, a right circular cone is a cone where the base is a perfect circle and the altitude, or the axes, from the tip of the cone to the bottom of the cone is a right angle to the plane of the base. So that's called a right circular cone. On page 350, they show you what they mean. Here is a plane, or a flat surface, and it is intersecting or cutting through. I guess it's really bisecting because it's cutting right through this right circular cone. And here are 4 different ways it can do that. So if the plane is also horizontal to the base, then its bisection here, the part that it cuts out, is going to be a perfect circle. Here are some equations for circles. Notice that there's an x and a y. They're both squared and they both have the same coefficient. So x squared plus y squared equals 6 would be the equation for a circle, or 2x squared plus 2y squared equals 15. The coefficients are the same. The coefficients of the variables are the same. Both variables are squared and they're added together. So that's the equation for a circle. If the plane bisects the cone somewhere up to the top, so it's not actually touching the base, but it does it at an angle, and it's not, the plane of the bisection is not parallel to the base, then it actually makes an oval or an ellipse. In mathematical terms, an oval is called an ellipse. And it's a tilted circle. The equation of an ellipse also has 2 variables that are squared. So we have 2x squared plus 3y squared equals 17, or x squared plus 5y squared equals 5. But the coefficients are not going to be the same. Okay? If, when the plane bisects the parabola, it hits the base, so there's nowhere left to go to complete the circle, we end up with a half circle filled in. Here's the graph. This is called a parabola. Okay? So a parabola is a half circle, or a part of a circle. It's not really a half circle necessarily, because the bottom of this parabola is hitting the base, so it can't go any farther. It can't complete the ellipse. Okay, the equation of a parabola is going to have one exponent squared, and the other one is going to not be squared. So y equals x squared minus 10x plus 23. Here's a quadratic formula. If you graph a regular quadratic formula, you get a parabola. Or y equals 3x minus 5. Okay, here's a trickier one. If you stack two cones, point to point, and then you have a plane that intersects both of them at the side, you come out with a hyperbola. So it's like a parabola, but doubled. And they're actually echoes of each other. This parabola is an echo of this parabola. This is called a hyperbola. Okay? Their equations look very much like the equation of an ellipse, but they're subtracted instead of added. So x squared minus 4y squared equals 4, or 4x squared minus 2y squared equals 6. They look a lot like the equation of an ellipse, but they're subtracted instead of added. We are not going to be graphing these conic sections this year. You're going to do that in advanced math. But it's important that you start to recognize the formulas. So as we see these, I'm going to be pointing them out to you. If the plane is tangent to the cone, so if a plane touches the side of the cone, but it doesn't bisect it, then the set of points where the plane and the cone touch would form a straight line. So a line can also be considered to be a conic section. There's some math theory for you. A nonlinear system of equations contains at least one equation which is nonlinear. These systems often have more than one solution because their graphs intersect at more than one point. So, here is the graph of a nonlinear system of equation. We have a circle and we have a line bisecting it. And you notice they meet at 2 points. So if we solve this equation for the points that they have in common, we're going to come out with 2 answers instead of just 1. This graph shows the line of 2x minus y equals 3, and the equation for the circle is x squared plus y squared equals 9. To find these points, we're going to be using substitution and elimination, just as before. These equations just get a little more complicated. Okay, so we're going to start by solving the equations we just saw. So here's the system: x squared plus y squared equals 9, which is the equation of the circle. See, the coefficients are the same, and this is added. 2x squared minus y equals 3, which of course is a straight line. This line is intersecting the circle in 2 places, so when we solve this, we're going to have 2 answers for both x and y. So let's start by solving the second equation for y. So we have 2x minus y equals 3. So if we add y to both sides and subtract 3 from both sides, this cancels and this cancels, and we have y equals 2x minus 3. Okay? this equation is squared. So if we square this equation, then we'll get y squared equals, and we can substitute it into that equation. So y squared equals 2x minus 3 squared, which equals 2x minus 3 times 2x minus 3. And we can solve this with FOIL. So y squared equals, this is 4x squared minus 6x plus 9, which equals 4x squared minus 12x plus 9 equals y squared. Okay, now we can substitute this into that and solve for x. So we have x squared plus this mess, 4x squared minus 12x plus 9 equals 9. Okay, we have x squared plus 4x squared. Oops, that's not squared. Oh, sorry. I lost track of what I'm doing. Alright, let's put the like terms together. So we have 5x squared minus 12x and let's move this 9 over here. These cancel, and so this equals 0. Now we can factor out an x, and we'll have 5x minus 12 equals 0. Right, we solved these before. We can say either x equals 0 or 5x minus 12 equals 0. And then we can solve for x here. This will be add 12 to both sides. And we get 5x equals 12, or x equals 12/5. Okay, so here are our two values for x. Now we need to solve for y. So we have x equals 0 and x equals 12/5. If x equals 0 and 2x minus y equals 3, then this is 0 minus y equals 3, or y equals negative 3. So the ordered pair for this answer is going to be 0 and negative 3. That's one of the places where the line bisects a circle. The other point is going to be x equals 12/5, so 2 times 12/5 minus y equals 3. So this is 24/5 minus y equals 3. So y equals 24/5 minus 3, which is 15/5, which equals 9/5. So this point is going to be 12/5 and 9/5. So these are the 2 points where this line bisects this circle. Okay? Let's try another one. We have b times td plus 5 times td equals 25, and b times td minus 5 td equals 15. The b is the speed of a boat, and the t is the time downstream. We will be doing many more problems like this later. So sometimes we're going with the stream, and sometimes we're going against the stream. When we're going with the stream, we go faster. When we go against the stream, we go slower. Okay? So both b and time of d are variables. We can use elimination as the equations are and solve for b td. and then use substitution to break it down into TD and B. Or we can solve for TD and then come back to B and TD. We're going to come out with the exact same answer either way. So let's just do it both ways and you can see. So we have B TD plus 5TD equals 25. B TD minus 5TD equals 15. Okay, if we just use elimination to get rid of these guys now, we have B TD equals, we have 2 times BTD, which equals 40. So B times TD equals 20. Okay, now we can substitute this back into one of these guys. So we have 20 plus 5TD equals 25. Subtract both sides. 20. And we have 5TD equals 5. So the time downstream is 1. Now we have to solve for B. So the boat times the time downstream equals 20. The time downstream equals 1, so B equals 20. Okay, so these would be your two variables in this one. If we did it the other way, so we are solving for BTD to start with, we're going to come out with the exact same answer. BTD plus 5TD equals 25. Let's change the signs on this one so we can use elimination. We've got negative BTD plus 5TD equals negative 15. Remember, we're changing the sign, so we change the sign all the way across. These cancel, and we have 10 TD equals 10. So TD equals 1. And then we put this back in there, and we have B times 1 plus 5 times 1 equals 25. So B plus 5 equals 25, and B equals 20. So whether you catch that you can get rid of both of them at the same time here, or if you do it this way, which is a little bit longer and slightly more complicated, either way you get the same answer. That is it for that lesson. Try your problems. You're going to see a few boats and downstreams, and you're going to see a few conic section equations. You try them. Let me know if you have any questions, and that's it.